base, and again, exponent rules rely on the same base. Here we have base of 256, base 9, base 27, base 4. This is a real problem because these bases, none of these bases match. However, we can re-express some of these bases with different bases. So for example, 9 really is a base 3 number, and we can rewrite that as 3 squared. So that's kind of where I'm going to start. I'm just going to start with that 9. And in the numerator, it's going to be 3 squared to the power x. Okay, so I'm just going to actually highlight just the 9 here, just the bases, because we're just focusing on the base first. Okay, this base 4, I'll do it in a different color here, this base 4 in the denominator. And again, we're just going to focus on the base, and I'm going to rewrite that base as 2 squared. And the power that was on there is 2x minus 3. Now what ends up happening in both cases is I have a power to power. However, we do have an exponent property that allows us to deal with that. Now, in taking a little bit closer look at these numbers now, well, 27 really is a base 3 number. If we look at our chart, it really is a base 3 number. And I can rewrite that as 3 to the power 3. And that becomes, that's the same as 27. And just maybe color code these here. And that 27 has the power of 3x, make that a little bit neater, 3x plus 1. And if we take a close look at the 256 as well, 256 also, although that's a little bit harder to see, this is actually a base 2 number. Now, these are kind of interesting numbers because you've probably seen these on when you look at computer memory. They tend to go up by doubling. So this is really a base 2 number. Okay, so that's really 2 to the power 8 in this case. Okay, so if you do 2 times 2 times 2 times, if you do that 8 times, okay, we should maybe just double check this, but 2 to the power 8, in fact, is 256. So there's our 256 written as a base 2. And then we can't forget the exponent. It's going to be a minus 3. Actually, this is a typo here. This should be really x minus 3. I'm just going to change that. Okay, that should be x minus 3. And so what ends up happening then is we end up with an exponential problem where we have bases that match, and we can apply exponent rules here. So I'm going to do the exponent rules here. So we have power to the power. So we're going to multiply the powers like that. Same thing here. This is power to the power. So we end up with 4x minus 6. On the top here, this is 3 squared to the power x, or 3 to the power 2x. Same thing here. We're going to multiply those powers together. So we have 3 times 3. And 3 times 1. And then we can combine these exponents, the base 2, so I end up with 8x, and I take away 4x's, so I'm left with 4x. I've got divide by 224 times, divide, which really means multiply, so I'm going to take away 3 or 6 divides from here because it's going to cancel. This is really times because it's divide in the denominator. This one here, we can either leave it in the denominator, but I'm going to make it negative in the numerator. I'm not really a big fan of negative in the numerator, but in this case it's not wrong. So I'm going to do 2x minus 9x, which is negative 7. And I'm going to take away the 3, because really that's divide in the denominator. That's divide and divide, because it's in the denominator. So I'm just going to express that as negative exponent, which really means divide. So there's our final answer. We've now, what we can do when we don't have bases that match, we can see if they're related bases, and we can make them match in this way.